All right, welcome to part 2 of lesson for week 6. We'll continue with our remaining topics and subtopics, that is boiling point. Boiling point is defined as the temperature at which the atmospheric pressure or external pressure becomes equals to the vapor pressure of the liquid is called as boiling point. As we know that we previously discussed that vapors, they start collecting on the surface of the liquid. These vapors, they start collecting on the surface of the liquid, and as a result they start exerting pressure on the surface of the liquid. Now at the same time we have another pressure, that is an external pressure. Sometimes that usually that is atmospheric pressure, and sometimes that may be some external, another additional pressure we might have changed or placed on the liquid. That is external pressure or simply atmospheric pressure. Any one of them can be there, that is also exerted. So when the vapor pressure of the liquid, that is exerted by the vapors of that liquid, becomes equals to the external pressure, this external pressure may be usually atmospheric pressure or may be some other artificial pressure created on that liquid. At that point the liquid starts boiling. This is called as boiling point of the liquid. This is called as boiling point. Look at the if I can, let me try to show you illustration. See, the vapor pressure is exerted at the towards the upside, and external pressure is exerting downside. So as a result of this, when these both pressures, they start they become equal. As a result the liquid starts boiling. All right. Boiling point. Boiling point is affected once again temperature at which vapor pressure becomes equals to the atmospheric pressure. Normal boiling point of water is 100 degrees Celsius. It means at this particular 100 degrees Celsius, the vapor pressure, the atmospheric pressure of the water will become equals to the vapor pressure, and at this particular temperature the water starts boiling. Boiling point is lower at higher elevation, so it means if the atmospheric pressure changes, if we change the atmospheric pressure, we can change the boiling point. It means the boiling point is actually dependent upon the atmospheric pressure or the external pressure. We may call it external pressure or atmospheric pressure. So direct relationship is there. If atmospheric pressure lowers, we can lower the boiling point. If atmospheric pressure or external pressure increases, or we can raise the boiling point of a liquid. So we can change the temperature at which a liquid boils by adjusting or bringing up changes in the external pressure of that liquid. In addition to external pressure, we also need to remember some additional things. In these additional things, we have low vapor pressure means high boiling point. If the vapors are less at that particular temperature, it means it will take still a long way to go to collect enough vapor pressure that becomes equals to the atmospheric pressure and bringing up the liquid to boil. So if the vapor pressure of certain liquids that is low, as we previously discussed in part 1 while discussing vapor pressure, that there are certain liquids like water, they have less vapor pressure at particular temperature, so it means they have high boiling point. Similarly, if we have high vapor pressure, like previously we discussed in the case of ethyl alcohol or diethyl ether, that has high vapor pressure even at less temperature, so it means they have more or low boiling points. They have less boiling point because they have high vapor pressure at a particular temperature. The third thing to remember is that the stronger the intermolecular forces, as previously we also discussed in vapor pressure as well, that the intermolecular forces are also affecting the vapor pressure. Lower the vapor pressure. Intermolecular forces are strong, like in water, it will lower the vapor pressure and the boiling point will be higher. So the increase in if there is the intermolecular forces are weak, the liquid molecules can easily be converted into vapors, and if they can easily be converted into vapors, more vapor pressure, and if more vapor pressure is there, it means low boiling point is there. For non-polar we have low boiling points, whereas for polar we have high boiling points. So that is inversely related. The intermolecular forces are inversely related with the boiling point. Factors affecting boiling point, as we have also discussed recently, that the nature of liquid affects boiling point, external pressure effects, and presence of impurities effects. Let's talk about how simply nature of liquid is. If the intermolecular forces are more, then it is a high boiling point. If the intermolecular forces are weak, it means the vapor pressure is more, and if vapor pressure is more, the boiling point is low. So we have the triple arrows. One is for the intermolecular forces are weak, lower. The center one is for the vapor pressure is high, and the third one is for the boiling point is low. Similarly, for the ones which have strong intermolecular forces, and it means the vapor pressure is low. If vapor pressure is low, it means the boiling point is high. So this is how the three arrows are interrelated with one another. Similarly, if we talk about external atmospheric pressure, more external atmospheric pressure, high external atmospheric pressure, high boiling point. Less external pressure, low boiling point. So two arrows are related directly. Presence of impurities, if the impurities are there, that will result in increasing the boiling point of the liquid. So that is the boil, and the sharpness of the boiling point, or the values may also tell us about the purity of a liquid as well. Nature of the liquid. Once again, let's discuss in terms of this graph that how nature of liquid is affecting the boiling points. As we previously discussed, the polar liquids have high boiling points. Polar liquids have high boiling points because polar liquids have strong intermolecular forces. This first arrow is for strong intermolecular. As a result, the vapor pressure is less, the second arrow, and if the vapor pressure is less, the boiling point is high, the third arrow. So for polar liquids we have high boiling points, and let me draw the same for non-polars. We have low boiling point. Non-polars have weak intermolecular forces. If weak intermolecular forces are there, vapor pressure is high, and if vapor pressure is high, the boiling point is low. So these three arrows are for the non-polars. All right, let's discuss this curve. This is the 760 mmHg temperature. This is 760 mmHg, the vapor pressure of the atmospheric pressure, and these are the vapor this line indicates the atmospheric pressure, and this curve indicates the rise in vapor pressure. At the point at which this vapor pressure becomes equal to the atmospheric pressure or touches the atmospheric pressure line will be the boiling point of that particular liquid. C. The diethyl ether touches the atmospheric pressure line at 34.5 degrees Celsius. This is, let us just draw it. It's something about here. So 34.5 degree Celsius is the boiling point of diethyl ether. As we discussed that it is non-polar, so the intermolecular forces are less, vapor pressure is high. You can see the rise in curve. The vapor pressure is high, the boiling point is low. So the boiling point is 34.5. Whereas let's talk about this ethanol, the second curve, it touches at 78.5 degree. It touches the, this is 78.5 degree. It touches the atmospheric pressure line. It is comparatively polar than diethyl ether, but less polar than water. So it belongs to the first category. The intermolecular forces are high, the vapor pressure is low, and if vapor pressure is low, the boiling point is high. Similarly, the last example is water. Look at the water is among the highest boiling points from out of these given liquids. So you can see that water is polar, highly polar. Hydrogen bonds are there. If hydrogen bonds are there, that makes it difficult for these molecules to escape and to form vapors. Others are less number of vapors are there, and if less number of vapors are there, it will take a lot more time for the vapors to be collected and exerting pressure equal to the atmospheric pressure. So that will boil at 100 degree Celsius. So water has high boiling point as compared to the other two liquids given in front of you, and this is because of the polar nature of the water molecules. All right, let's talk about the effect of pressure on boiling point. If lower pressure would be there, external pressure, by pressure over here we means external pressure, the boiling point will be less or low, and if the external pressure is high, the boiling point will be high. So direct relationship is there. Lower pressure would lower the boiling point of water. Water will boil very quickly on the mountains of the top, but the temperature reached is lower than 100 degree. So at the mountain tops, water may boil below 100 degrees Celsius. This is because the atmospheric pressure at the mountains is low. So if atmospheric pressure decreases on the mountains, this results in decrease in the boiling point of water. Whereas if increased pressure is there, this may result in increasing the boiling point. That usually happens in pressure cookers while cooking things. Then cooking is made easy by the use of pressure cookers because the underlying technology is that we increase artificially the external pressure in pressure cookers. As you know, a weight is put on the lid, and this weight actually increases the external pressure on the liquid, and this results the liquid to boil at a higher temperature, that is about 101 or 102 degree Celsius. So this also, we can also increase the to 2 atm. The external pressure of the pressure cookers may increase to 2 atm, and really thus helping us to boil the liquid at 120 degrees Celsius and making our cooking easy. So this depends on how much external pressure we increase. That depends on how much external pressure is increased, and that is ultimately going to increase the boiling point in respective manner. Here is an illustration also given in front of you people to show you the variation of the boiling point at different temperatures. Let's discuss it. See, the first, at sea level, the atmospheric pressure at the surface of water is at 70 degree is greater than its vapor pressure. Bubbles of vapor cannot form in the water and it does not boil. So the at sea level 70 degree Celsius, the vapor pressures are not enough that they become equal to the external pressure of 101.325 kPa. So we need it. It will take longer time to reach or to able to make up such an equivalent vapor pressure at the sea level. Whereas sea level at the boiling point, if we increases the temperature to 100 degrees Celsius, at 100 degree the vapor pressure becomes equivalent to 101.325 external vapor pressure, and as a result the liquid start boiling at 100 degrees Celsius. Whereas at the top of Mount Everest, what happens, this results in lowering the external pressure. At Mount Everest the external pressure is lowered to 34 kPa, and to make up an equivalent vapor pressure to 34 kPa, the liquid may boil at 70 degrees Celsius, because at 70 degree enough vapors have been collected that becomes equals to the 34 kPa external pressure easily, and the liquid boils at 70 degree. Whereas as you have been shown that previously at sea levels this temperature 70 degree was not enough to make up equivalent vapor pressure, so we needed to heat up till 100 degree. Whereas at Mount Everest, as the external pressure has been lowered, so that can be made up by heating at 70 degree. Similarly, I also want to show you I also want to discuss over here with you people the case of increasing the external pressure. In pressure cookers, the external pressure is increased to 2 atm, and as a result of this increased external pressure the boiling point is increased to 120 degree Celsius. So you need to know both the cases of lowering the boiling point, as well as of increasing the boiling point. We have the boiling point is lowered when the atmospheric pressure is lowered, as in case of Mount Everest. The boiling point is lowered to 70 degrees Celsius for water. Whereas you also need to know the case or the example when boiling point is increased by increasing the external pressure, as that usually happens in case of pressure cookers. So please remember both the examples, recall both the examples. One of the case for lowering the atmospheric pressure and resulting in lowering the boiling point, as in Mount Everest or Murray Hills. Whereas another example is for increasing the atmospheric pressure and increasing the boiling point, as that happens in case of cooking with the pressure cookers. All right, there is now some practical activities also given in your books to follow. One is regarding determination of boiling point of an organic liquid. The apparatus shown and the procedure is also listed. You need to see the apparatus in diagram. There is a stand, and you need to all right, let me show you. This is the apparatus used for finding the boiling point of an organic liquid. Thermometer is used. A water bath, or you may call it a beaker filled with water, is there. In this beaker you are hanging one of the liquid in small fusion tube that is attached with the thermometer, and then you start heating it. There is a stand. This stand is called you may call it a holder or a stand is there. There are some apparatuses required, including beaker, thermometer, fusion tube, capillary tube, then Bunsen burner is there. We will also perform this activity when once you people are back to school. Till then, you just have to go through the content that is given in your book regarding this activity. That is more than enough for you people at the moment, because once you will perform it with your hands, then you will learn more. All right, then it is a distillation process or activity is also given to you. Distillation is the process in which the two liquids are separated by the help of using the difference in their boiling points. The basic technique behind this separation is to use the difference in their boiling point. So we just, in this flask, the two liquids are mixed together, and there lies a difference in their boiling point. So we start heating that mixture of the liquid. As a result, one of the liquid will boil first, will be converted into vapors first, and these vapors are collected by cooling them down over here, by condensing them in the condenser, and there is a flow of water taking place around the condenser that helps the vapors to condense, and these vapors are collected separately in this separate beaker. There is a thermometer attached over here to show you, to indicate us with the respective temperature, because we have to keep an eye on the temperature as well, because if we will ignore the boiling points of the two liquids, then once again the mixing will start taking place. So we need to keep an eye on the respective temperature, so that as long as the temperature is close to the boiling point of one of the liquid, the vapor pressure of that particular liquid is collected, and as long as the temperature of that other liquid comes close, we have to stop heating, so that mixing may not take place again. We will also perform this distillation activity in lab as well, but so far you are directed to please go through the content, respective content of this activity in your books, just to build up an initial understanding of this process. All right, let's talk about recap of the week 6. In this week, we discussed, in this lesson, we talked about evaporation. Evaporation is the conversion of a liquid from liquid state to gaseous state. And we also discussed how evaporation results in cooling effect. Evaporation takes place at all temperatures, and it is affected by the factors like surface area of the liquid, temperature, and intermolecular forces of the liquid. We also discussed vapor pressure. Vapor pressure is defined as the pressure exerted by the vapors of that liquid on the surface of the liquid. Higher the temperature of the liquid, more vapors will be formed. More vapors will be formed, more vapor pressure will be there, and more vapor pressure will be there. Then it will take less time to the liquid to boil. So if the vapor pressure is high, low boiling point of the liquid is there, and if the vapor pressure is low, high boiling point of the liquid is there. As the vapor pressure gets equal to external pressure of the liquid, then this refers to the boiling point of the liquid. Boiling point of a liquid directly depends upon external pressure. Therefore, water may boil at different temperatures at different altitudes. We also discussed the two cases, how we can lower the boiling point of water and how we can increase the boiling point of water respectively. So this was all about recap of week 6. All right, what to do next? Now you people are directed to access to the resource folder and go through all the content that is given to you and all the links provided to help you with further understanding. You people Also directed to complete the written assignments associated with each subtopic and grade them with the key provided to you later on. You need a lot of learning and written practice for the reasoning questions and the pressure unit conversions as well. So for now, stay safe and stay home. Have a healthy fasting and good luck. Thank you.